So we're asked to write down the next term and the general term for each of these sequences. So let's think about what's happening term to term here. We can see that each time we're adding on 3.5. So 54 plus 3.5 means the next term is going to be 57.5. And the nth term, well, this is a linear sequence, and you might recall from previous studies that for a linear sequence it is always equal to whatever that thing that we're adding on is, so 3.5n. And then if n was equal to 1, we would have 3.5, but we need the first term to be 43.5. So we add on what we need to get there, so we add on 40 in this case. Now if you can't remember how to do that, or you're not sure you've seen that before, don't worry, in the next skill 4, we're going to be looking specifically at linear arithmetic sequences and how we can find this using a particular formula. So don't worry too much about that one if you weren't sure about it. For part B, we can see that the numerator is always 1, so we know that the next term is going to be 1 over, and then if we look at the denominator, we see, well, what patterns can we see? The first thing I'm thinking is we're adding 4, and then we're adding 6, and then we're adding 8, so the next one is we're going to add 10. So 1/30th. So the nth term here is always going to be 1 over something. So we know that it's going to start as 1 over something. But how do we find what that goes on the bottom there? And this is actually a quadratic sequence. And so to think about a quadratic sequence, let's think about what is n. N is 1, 2, 3, 4. And let's think about n squared. That's 1, 4, 9, 16. And what we're trying to find is how can we combine these in some way to get those? Well, actually, you might spot here that n squared plus n is equal to 2. 2 plus 4 is equal to 6. 3 plus 9 is equal to 12. And 4 plus 16 is equal to 20. So actually the nth term of the denominator is n squared plus n, so our complete nth term is 1 over n squared plus n. That's a quadratic sequence, and actually it's not in this course, so again, if that was a little bit not something that you're aware of, don't worry too much about it. It's just about how we can get to nth terms. There is one more here, which is this one here. And in this one, there's a few ways of looking at this one. So one way of looking at it is that we are halving each time. Another way of looking at it is similar to the one above, which is it's always 1 over, and then the number on the bottom is doubling each time, because we can think of 1 as 1 over 1. So if this is doubling each time, it's 1 over 16. So in a similar way, we can think of this as 1 over, and then these numbers here are actually the powers of 2. 2, 4, 8, 16 are the powers of 2. But it's not quite 2 to the power of n, because 2 to the power of n would start at 2 when n is equal to 1. It's 2 to the power of n minus 1. When n is equal to 1, we get 2 to the power of 0, which is 1. When n is equal to 2, we get 2 to the power of 1, which is 2. When n is equal to 3, we get 2 to the power of 2, which is 4, and so on. Or we might have written this as 1 over 2 to the n minus 1, using laws of indices. We can transform between those. And this is a type of geometric sequence. And again, a bit like the first one, if you didn't follow that completely, don't worry. In skill 5 of this unit, we'll be coming back to looking at geometric sequences in a lot more detail and how we can get to this form very quickly using a particular formula.